Hello, my name is Michael Veltre, and I'm a senior at Duquesne University. First off, I would like to thank the Department of Energy, the National Science Foundation, and the Thomas Jefferson National Lab for providing me with a lifetime memory and experience over the summer. I would also like to thank Dr. Harut Avakian and Dr. Fatia Ben Mokhtar for their mentorship and guidance through my research journey. My research was comprised of coding and data analysis. Dr. Avakian would conduct Monte Carlo simulations in order to acquire data, and from there I could extract the desired quantities to compare with data collected from semi-inclusive deep inelastic scattering experiments. Through semi-inclusive deep inelastic scattering, commonly referred to as SIDIS, of electrons off proton and deuteron targets in Hall B at Jefferson Lab, hadrons are emitted at various angles and momenta. After being produced in the hadronization of quarks, these hadrons are detected by the CBAF Large Acceptance Spectrometer, also known as Class 12. Through the analysis from the Class 12 detector, Hall B of Jefferson Lab can distinguish between hadrons, particularly pions and kaons. The goal of this project is to make measurements and comparisons of the momentum and angular distributions of pions and kaons using various datasets. This will be achieved with the analysis of pions and kaons resulting from the SIDIS data and comparing the results to two different Monte Carlo simulation datasets with different relative contributions from pions and kaons. Monte Carlo is a simulation designed to help predict and understand the events that will occur in the experiment hypothetically by running the experiment virtually. The data will be analyzed by means of Java as the primary language and utilizing Class 12 software for more intensive data analysis while running the code using Eclipse, an integrated development environment. The Class 12 software allows for the use of specific classes and methods that provide a simpler interface to identifying and analyzing particles' desired quantities, like the momentum and angular distributions, and calling them into histograms, for example. I will show the momentum and angular distributions of pions and kaons, and the comparisons between the SIDIS data and the Monte Carlo datasets with different relative contributions for pions and kaons. The Class 12 SIDIS Monte Carlo has been tuned to achieve better agreements with experimental measurements to get the kinematical distributions for pions and kaons. By getting Monte Carlo as close as possible to the low luminosity data, Monte Carlo can be used for efficiency studies. Moreover, realistic Monte Carlo can be used to better understand the response of such a complex detector as Class 12.